In this exercise, we're going to explore the PRAG calculation level in Quicksite. PRAG is one of the three level aware calculation, and it's probably the trickiest one to understand. So what does PRAG actually do? It first respects any filters you've applied, then performs calculations at the row level on that filtered data before any aggregation happens in your visual. This is useful when you want to compute independent of visual groupings in the analysis. Let's look at what we've set up for this exercise. We're using the superstore data set, and we have two table visuals already configured. The first is the region table. It has region on rows and cells with an average aggregation on values. This gives us average cells by region. The second is the product table. This one shows product name, region, sales as an average, and a count of product name. Note the two filters. The region filter is set to Central and East, and the product name filter is set to ACCO 3-hole punch. The filters are only impacting the product table. They are not impacting the region table. Now let's create our PRAG calculated field. I'll name this field Cells per Product PRAG and enter the calculation. Let me explain the syntax. The average over function calculates an average. Sales is our measure, and notice we're using cells directly, not sum of cells. That's important. PRAG, like pre-filter, requires a non-aggregated operand. The square brackets contain our partition field, which is product name. PRAG is our calculation level, telling Quicksite to first apply any filters, then perform this calculation at the row level on the filter data before any visual aggregation. I'll click Save. Now let's add this field to both visuals to see how it behaves differently in each context. First, I'll select the region table visual and place cells per product PRAG on the values well. I'll click the kebab menu next to the cells per product PRAG in the values well, and next I'll select aggregate, then average. Now I'll select the product table visual and place cells per product PRAG on the values well. This one will default to min, which is fine. Before we analyze the results, let's configure a useful filter behavior. I'll select the region equals filter control. I'll click the pencil icon. This opens the Format Control panel on the right side of the interface. Under Control Options, I'll enable Show Only Relevant Values. A pop-up will appear asking which field to use. I'll select Product Name and click Update. What does this do? When enabled, the region filter will only show regions where the selected product actually has sales. Since ACCO 3-hole punch has no sales in the South region, the South option disappears from the region filter. Now let's analyze what we're seeing in both tables. I'll make sure that Select All is checked in the region equals filter. Looking at the region table, I'll note the different cells per product PRAG values for each region. Looking at the product table, I'll note that every single row shows the same value, $15.28. What's going on? I'll explain. In the region table, we're looking at all products across all regions. The PRAG calculation first applies any active filters, then assigns each transaction row a value equal to its product's overall average calculated across the filter dataset. Let me walk you through this with an example in Excel. In this spreadsheet, in section 1, you'll see 31 transactions from the superstore dataset. We have 4 products across 4 regions. Column D shows the actual sales amount for each transaction. Column E shows the sales per product PRAG value. Let's scroll down to section 2. This shows the product level averages. The white business envelopes have 7 transactions averaging $69.84. The recycled envelopes have 10 transactions averaging $28.67, and so forth. Now, going back to section 1, let's look at column E. Every row for white business envelopes shows $69.84, regardless of the actual sales amount. Every row for recycled envelopes shows $28.67, and so on. Here's a striking example, rows 11 and 12 in the East region. Both are office refrigerators. Row 11 has an actual sale of $208. Row 12 has an actual sale of $1,040. Both rows show $451 in the pre-ag column because that's the product's overall average. Now look at section 3 to see how this affects the regional calculations. The sales average column takes all the raw sales values in column D and averages them by region. East has 5 transactions totaling about $1,423, so the average is a little under $285. The pre-ag average column takes all the pre-ag values and averages them by region. In the East, we have the same 5 rows, but now we're averaging at the product average level. That gives us about $214. The difference is significant. East sales average is almost $285, but the pre-ag average is lower at about $214. Why? Because that one large refrigerator sale of about $1,040 gets replaced with the product average of $451 before we aggregate by region. The pre-ag column essentially normalizes each transaction to its product's typical value. Then the visual averages those normalized values. The product table tells a simpler story. Since we filtered to just one product, ACCO 3-hole punch, every row in the table is for that same product. The pre-ag calculation partitions by product name, so it calculates the average sales for ACCO 3-hole punch across all filtered transactions, which equals $15.28. Every row gets that same value because every row belongs to the same partition. When we filtered to one product, we made the partition constant across all visible rows. The math works like this. ACCO 3-hole punch has 9 transactions across Central, East, and West. Central has 4 transactions totaling about $49. East has 4 transactions totaling about $74.50. And West has 1 transaction of about $14. Add these up, divide by 9, you get $15.28. Pre-ag is most useful when you want to calculate on a dimension that isn't displayed in your visual. In our region table, product name isn't displayed, but pre-ag lets us incorporate product level calculations into the regional view. If you've used Tableau, this is similar to an include level of detail expression, which adds dimensions to the calculation that aren't on the view.